The problem we are working on is how to figure out, well, if I burn 300 grams of methane, how many grams of water are going to be created? In our first video, we talked about what a mole is, what molar mass is, and we found the molar masses of our reactant, methane, and our product, water. In video 2, we learned about how to convert grams of methane to moles of methane by dividing the molar mass. And we explained why we divide by using this example in red. 50 pounds of cans at 10 pounds per can means I have 5 cans. Our third video, we learned about how to convert from moles of reactant to moles of product. We talked about how the chemical equation tells us how much reactant and how much product there are. In this case, it says that 1 mole of methane makes 2 moles of water. So if we have 18.7 moles of methane, we got to multiply by 2/1 to get my final answer of 37.40 moles of water. In this case, for every 1 mole of methane, I make 2 moles of water, which is why I did times 2/1. With a note, if you follow this note in red, you'll always do it right. Since I started with moles of methane must be on bottom. All right, moving right along. Our last step. We now know that we have 37.40 moles of water. I want to know how many grams of water this is. Okay, well, first up, I need to find my molar mass. I did it up here. It's 18.015. So here we go. Come on now. 18.015 grams in 1 mole, in 1 group. So I'm saying, hey, I got 37.4 groups. 1 group is 18 grams. Am I going to multiply or divide to get this answer? And the answer is you're going to multiply. If I have 37.4 groups and it's 18 grams for 1 group, I'm going to have 37 times more than that. So I'm just going to get out my calculator now. 37.4 times 18.015 equals 673.76 grams of water. All right, now, does that make sense? Well, okay, if I have 18 grams for 1 group and I have 37 groups, no, we're going to get a pretty large number. So that number makes sense to me, which means that 37.4 moles of water weighs 673.76 grams of water. And there we go. That is stoichiometry. Let's go ahead and zoom out so you can see everything all at once. Now, there is I don't want to call it a shortcut. There is a way to do all of these steps all together, but I really don't suggest you do it unless you're really good with math and you're really good at understanding fractions. So if that's you, keep watching. If that's not you, please just turn off the video now, use this page of notes, and you're going to be fine and you're going to get everything right. Now, for those of you, though, that are curious about that last piece, how could I do all of this all together? Okay. Whew. Let's do it. When you do it all together, it's called dimensional analysis. And this is how you'll do it if you ever take a college chemistry course. So this is just in case you're curious. And what you would do is this. You would say, well, I got 300 grams of methane. I know that I have 16.043 grams of methane is 1 mole of methane. I would say that 1 mole of methane creates 2 moles of water. Reading that off my equation there. And I know that my other molar mass is 18.015 grams of water is 1 mole of water. Now here's what I would do. Multiply, multiply, multiply equals, but I'm not done yet. Grams CH4. If you think about a fraction, what happens if you have 2 times 3 over 2? Let me say that. If you have 2 times 3 over 2. Got a little fraction bar there. Oh, it's not going to want to do it. There we go. Well, hopefully you can see that that's equal to 3. Because what happens is that if something is on top and bottom of a fraction and they're being multiplied, they cancel out. So what I'm going to do here is grams of methane. So I'm going to put grams of methane on bottom of my fraction and moles of methane on top. But look at that. Multiplying by 1 over 16 is the same thing as dividing by 16. Then I'm going to multiply by, okay, moles of methane's on top, so I want moles of methane on bottom, moles of water on top, multiply by 2, same thing I did here, and then moles of water on top, so moles of water on bottom, so grams of water goes on top, so I multiply by 18, which is what I did here. This is what it looks like when you're in college. But please note that it's really this exact same thing that we're doing. We just did it in lots of little steps. All right, that brings us to the end. Again, this bit on dimensional analysis, totally optional, not useful for most people. So I'm going to go ahead and put a box around it so we don't forget that this oh, nice. That this, here we go. Is the college level. All right. Congratulations. You now have a finished page of notes, something you can use to do every lab and the test in this unit. Congratulations.